Hello students and welcome to the new module where we are going to talk about the HDL coding concepts. We have decided that we are going to work with Verilog and not with VHDL. So in this video we are going to talk about that what exactly is Verilog, application of Verilog, and what is the structure of a typical Verilog program. So let us get started. So first of all, we have the question that what is Verilog? Well, Verilog is a hardware descriptive language. In short, it's called HDL. It is used for describing the digital system. Describing means we will write the text code for the given system. We can design systems like ALUs, timers, counters, microprocessors, shifters, and a lot of such systems, and we are going to do that in our training program as well. We will be designing these systems, and once we do that, if we send our code for the fabrication, then the HDL design is independent of the technology that will be used in the fabrication. There are technologies like 90 nanometer, 180 nanometer, 45, 22, and recently we work with 11 and 7 nanometer technology also. You don't have to worry about in which technology the design will be fabricated. So HDL implementation is independent of that. Knowledge of digital systems, digital design, and HDL is required for a front-end VLSI engineer. Let us talk about the Verilog program now. A Verilog program usually defines a module. Technically, we call the function or the whole program as module. The entire code will be written inside these two keywords. The first keyword of your program will be module and the last keyword will be end module. The code written in between these two will include additional things like port declaration, their directions, output and input ports declaration. Then we will also mention any extra signal required and the relation between all the input and output ports. So this is what we will do in a typical Verilog program. Let us look at the template. So as we said, the code is consisting of first thing, module definition. It will be the name, like I want to make a full adder or I want to make a vending machine. Then we will list all the input and output ports. What are ports? We will discuss that in detail. Declaration of additional signals. Then if we want to call some smaller circuits, some smaller modules, that technique is called module instantiation. We'll discuss that about this as well. And then we describe the system using different Verilog coding styles. Once this is done, let us look at the structure now. I have module, then we will give the name, and in brackets we will mention the port list. Port list means which variables are my inputs and which are my outputs. So list of input variables and output variables, these are called ports in Verilog. Now if I need some additional variables, some temporary variables, these are called signals, and we will declare them. Then we will write the code of our complete module. We will describe the relation between input and output, and then we say end module. So this is going to be the typical structure of a Verilog program. Now let us talk about these things, individual components in detail. Module is a block of Verilog code and it will implement the given specified functionality. One module can be part of another module and it can be controlled by other. If we make one full adder, 1 bit full adder, and then we want to make a 4-bit adder, so we can call these 1-bit adders as the component of our larger system. Modules will communicate with each other through ports, input ports as well as output ports, and the file name which we have will be same as our module name. So there should be some rules that we have to keep in mind while naming the module and files and all the other identifiers. So first of all, it should start with an alphabet. It can be in the small letters or capital letters or underscore. So only these symbols are allowed to start. Then the remaining characters can have alphabets, numbers 0 to 9, underscore and $sign. No other special character is allowed, and the maximum length can be 1024 characters. The next component in our Verilog code is port. Ports are the input and output variables. If we talk about other programming languages, in Verilog we call them ports. So if you look at this block diagram, for the larger module there are 3 ports which are input, in1, in2, in3, and there are 2 output ports, out1 and out2. So ports are these signals which will act as input and output for a given module. They will help in the communication with the other modules. So if you look at sub 1, there are 4 ports A, B, C, D, and they are connected to other ports of other module. So sub 1 can communicate with other modules through these ports. The ports are like pins on a fabricated chip, and ports are of 3 types: input and output. These we have already discussed, and there is another type which is called in-out. In-out can be a port which is input as well as output. That means when we have feedback. So when we will start coding, we'll discuss these type of ports as well. Next important component is the assignments. That means how do we write the code. The assignment syntax, it will start with the keyword assign, and after that we will mention which signal or port need to be assigned. We can also mention the drive strength and the delay as an option. So here is the syntax. We'll mention assign, then the name of the signal which is net expression, then in the square brackets we have optional things, drive strength and delay, and then we will say what is the value that should be assigned to this signal or port. Now let us look at one sample Verilog code. I have my module. The name of module is full adder. Then I have input variables. There are 3, A, B and C underscore in. There are 2 output variables, cout and sum. All of these are inside the bracket, and then we are ending with a semicolon. The next thing is we have the assign statement, where we are assigning output equal to addition of all the inputs. Once the assignments are done, there can be multiple statements here. Once those are done, then we say end module. So this is one very simple Verilog code, but to demonstrate you about the structure of a typical Verilog code. So students, now that we know about the structure, we'll talk about different coding styles in the next video. Keep learning. Thank you.